Hello everyone, Krishna this side. So in this video, I'll be covering this GeeksforGeeks problem, binary tree to circular doubly linked list. I think the today's lead code problem is kind of easy, and yes, I thought of covering few of the linked list questions as well on this particular channel. So decided to pick this particular question, and the problem statement itself pretty much gives us the clarity like what we have to do in this particular one. So we have given a binary tree and we need to convert it into the circular doubly linked list. Okay. While converting it, we have to just take care of few points. The left and the right pointers in a node will be used as a previous and the next pointers respectively in circular doubly linked list. Okay. So yes, with the help of the same node, we have to convert it and we have to return the circular doubly linked list. In that, we will just utilize this left and right pointers as a previous and next pointers. Okay. The order of nodes in the circular doubly linked list must be same as in order of the given binary tree. Okay. So yes, while when we are processing this binary tree, we will try to use this binary tree in order traversal, and with the in order traversal, whatever the result that we get it, that is like how the result similarly the circular doubly linked list result basically looks like. Okay. So yes, we have to make sure that the order of the circular doubly linked list is kind of similar to the in order traversal of the binary tree. The first node in the inorder traversal, leftmost node in the binary tree must be the head node of the circular doubly linked list. Okay. So yes, the idea is pretty much straightforward now. Let us directly see on the screen how we can solve this one. So here, let us suppose this is the binary tree that has been given, and when we try to convert this binary tree in the form of this in order traversal, right? So when we try to get the in order traversal of this binary tree, this is how the code looks like. I guess it should be clear to all of us, right? How we can convert the binary tree in form of in order traversal, or like all the different traversal techniques that we have, we should be having clarity. So in order traversal, whichever is the root, okay, sorry, the root is actually middle part of the entire tree. Okay. So first we process everything from the left side, whatever the data that is available in the left side, we will process it. So we will print all of them. Then we will print the root of the node, that is like it is actually available in the center point of this left side and the right side. And then we will start processing the right side of the data from this binary tree. Okay. So the idea is pretty much straightforward. What we do is basically we'll go in the left side. We will keep on calling the left nodes until left is basically equals to null. So root is basically equals to null. So that is the base case condition that we have. So root equals to null. Then we will simply return back. So once we return back, the this is like here we return back. Now we will print that root. So root is basically 2. So 2 is something what we have printed. Then we will call right side of that particular node. Okay. So once we are calling the right side, we have 3. Again for 3 the same operations happens, the left side is null, so we return back to this 3. So 3 is something what we print. Okay, left side is actually null, so we print that 3, and we try to go in the right side is actually null, so we are done. The moment this is done, this function basically been called from this 4, right? Initially it has been called, so the callback reached to this 4. Okay, while backtracking we'll reach back to 4. Now for this 4, we are basically printing it because left side code we have already generated. All the things in the left side of this code we have done. This is like we are printing the root. Now the root is basically 4. Okay. The moment 4 is been done, what we do, we are again calling the right side of this code. So right side of the 4, we reach back to this in the right side. Again for this right side, the root is basically 7. For 7, it is like 6. We call the left side of the node. Okay, the same operations, it will keep on doing it since we are doing it in recursive order. For the 6, we don't have anything in the left side. So yes, 6 is something what we have to consider right over here. We reach back to the 7. For 7, like we have right side, but before the calling the right side of that, we are printing the 7. 7 is something what we printed, and then we call to the right side and we print it ultimately because we don't have any child for this 9. Okay, that's how the in order traversal basically looks like. Just give a quick recap about this in order traversal of this binary tree. Now, this is how the code basically looks like for the in-order traversal. And if we try to see this same thing that is basically resonate for the circular doubly linked list. Okay, only thing is like between this 3 and 4, we have a next pointer and the previous pointer. That is like next is like basically the right pointer. So this 2 is pointing to the 3. That is next is for this 2 is 3. and previous for this 3 is basically 2. Same operations we are doing it. That's how it is basically looks like. Okay, only thing is like we are just introducing another next and right pointers. These are the things that we are doing it. So while doing that operation, this is the area where we have to do while printing it. So the moment we got any node, we are doing that operation and then we are going ahead. Okay, so while doing this print operation, there only we have to do some modifications. And majority of the questions from this doubly linked list, we basically solve them with the help of 2 pointers. So this question also we will try to solve with the help of 2 pointers, and we will try to see how we can do that. Okay, so initially this is how the data basically looks like. Okay, so we will utilize the same functionality how we have this in order traversal, the code that we have this in order traversal, we will try to use the same, but we'll do some modifications. What are those modifications, right? Like as I said, majority of the questions from this linked list, we can solve them with the help of 2 pointers. So we will try to use the 2 pointers and see how we can do it. So outside of this particular one, what I'll do is I'll create 2 nodes. Okay, the first node is head, because we need head pointer at this particular location, correct? And I'll create another node which basically keeps track of previous nodes, because we are actually creating 2 pointers and previous nodes needs to be pointed. So yes, for that, like previous node is something what I'll create initially. You will get this idea like what we are doing. Now in this particular print node, we will try to write some code. Okay, what is the idea? Now the first initially 2 is something what we got from this left. The root is basically pointing at 2, correct? Because for this 2 left there is nothing, so we reach at this one. So root is currently pointing at this one. Okay, so root dot left we tried, it returns. Okay, it simply returns. So this is done because its left side is null. So its left side is null, so it returns back right over here. Now after returning, the root is basically pointing at this 2, correct? That is the idea. So initially we check that if, okay, inside here I am writing this code, if the head is actually null, correct? If head is actually null, what we do basically, we will keep this whatever the root that we have, because that is the leftmost data information that we have in this particular binary tree. So their head will keep pointing, right? That's the idea, whole idea right over here. Head should be equals to root, correct? Now head since pointed, we are not interested again in future to modify this head. Okay, so head should point only once. That is something what we have done. Now once head is done, what is the next ask? So we have to make sure that there is another pointer. Okay, let us suppose previous also we are pointing at this particular location initially. When we go back, okay, when we are moving back, the backtracking is something what we are doing it, we should have idea like what was the previous node, so that wherever I am currently at, this 3 is something where I am, so previously whichever the previous node that we have, I can have this pointers. Okay, so that we are maintaining this another pointer. Okay, previous pointer. So initially we will check same for the previous, if previous is null. Okay, if previous is null, that means previous is also not pointing anywhere. So same thing we will do here, the previous will point to the root. Okay, previous will point to the root, and the moment this is done, what we will do, we will try to call this one function root dot write. Okay, this particular thing. Now when we call to this one, the call reach to this location at 3, correct? Now call is actually at this particular location. Okay, just focus right over here. Now only thing is like we just need to modify slightly. Now head is basically pointing to root, previous is basically pointing to root as well, that was 2. Now we called to the right side, the root is basically now pointing at this one. Okay, our root is basically right over here at 3. When this function calls this function root dot right, root is basically pointing to 3. Okay, that is the idea. Now root, we will check root is null. No, it is not null. We will try to go in the left side, it is null. We will reach back right over here. Once we reach back right over here, this particular piece of code which we are trying to write in this particular intermediate code, there the call goes. Now root is 3. Okay, root is 3. So here we check that head is null. Head is not basically null. This is condition is passed, we are not entering in this one. Previous, we check that previous, if it is null, previous is not null. So if previous is not null, we got to know that there was previous node where we need to make sure this whatever the root node that we have, its left pointer should point to there. Okay, the idea is pretty much clear right over here. So what we will do, if previous is not null, in this case only, what is the idea? In this particular case, what we will do, basically this 3 where the root is pointing, so it's root dot left side, root dot left side. Just focus right over here on the screen as well. Root dot left side, because root is currently pointing at 3, so root dot left is basically pointing to the previous one, correct? And the previous dot right, it basically points to the root. I guess the idea is pretty much clear. Root dot left point to previous. Okay, it is actually taking some time to update. And this previous dot right, okay, this previous dot right, it basically points to the root. Okay, I think this should be clear. The moment it is done, the moment it is done, our goal is to shift this previous pointer to 3, because when we reach to the 4, again same operation we are actually kind of looking at. Okay, so what we will do, this previous now points to this particular root. Okay, this previous basically points to this root. Here the previous is now pointed. Okay, at 3 the previous is pointed, so I just need to update this previous equals to this root. I guess that's it. Now this same code should work fine going ahead. Previous should point to root. Okay, previous equals to root. Okay, now this is done. Now previous is basically pointing at 3. For 3 and 2 we are done. So this callback is basically goes again back to the this left side of the piece of code is where for this 4 we have done. For this 4 we have done. So again 4 is actually the root. For the root we come right over here. Head is not null, that is satisfied. Previous is not null, that is satisfied. So we enter into the else condition and else condition. For this 4, 4's left side is previous right side is this root, and this previous basically points to 4. That is the idea. So simply previous will update to the 4. Now for this 4, we are again calling to the right side. Okay, the middle part of the code is been done. So for this 4, we will call to the functions dot right. So okay, function in the right side of the code we will go. This callback comes right over here. Okay, for this 4. Left side first code we have done for this 4. The 4 is also been done. Now previous is basically pointing to 4. Now again this callback goes to root dot right. Recursively we will keep on calling to the right side. So same operations keep on happening for the right side. 7, 6, 9 is something of the data that we have. Similar kind of operations we will keep on doing it. Okay, so that's how we can write this particular code. You can take another example and you can keep on doing the same operations. So what we have done, we have simply utilized the in order traversal of the code. We have this idea that most of the questions in the binary tree we can solve it, sorry, in the linked list we can solve it with the help of 2 pointers. The head basically points to initially 2. Okay, if it is null and we are not moving this head pointer at all at any point in time, and this whatever this previous pointer that we have, we are maintaining at the current root node, so that whenever new node is there while backtracking or we are exploring to the right side, we will make sure that previous was there where we can perform this left and right operations in between that, these doubly pointers that we have right in between that, those we can propagate. The moment that we are done, we will shift our previous pointer to the current root node. Okay, this way previous will at the end point to this 9. Okay, previous will point to the 9 at the end. Now once we are done all these operations, what we have to do, head, simply head is currently pointing to 2, heads left is basically pointing to 9. Okay, that's how we can create this circular linked list. And previous right pointer, previous, okay, previous node where it is pointing, its right pointer should point to head. That way we can create doubly linked list. If this circular linked list, if that was if the ask is not this circular doubly linked list, we will not do this particular operation. We will simply perform this conversion of binary into the doubly linked list. But if it is asked to convert into the circular doubly linked list, we will just create these 2 extra pointers where previous of right will point to the head and head of left point to the previous. Okay, that is the simple goal. I think this idea is pretty much clear what we are doing in all. So yes, let me write down this code as well. The first thing that we will do right over here is we will create another function. Let me create outside 2 pointers. So that is like, I don't want to change this, manipulate this head and previous pointer. Okay, so that's why I have created them outside. Okay, these 2 pointers I have created, and let us call this b tree, and inside here let us pass this root, and this will do our all operations. The first thing is like let us write down this code tree, and inside here it's like root. Okay, we'll check that if base condition, this is the base condition, if root equals to null, we will simply return null. No, we are not returning it, right? It is void function. So yes, return, we will simply return back from this one, from where the call has been came. Now we will try to call the left side of the tree, root dot left. Okay, the moment this is done, whatever the extra code that we have written in between that, that is something what we have to write. But before that, let me just finish this function, root dot left, right? Okay, that's how the in-order traversal looks like. Inside this particular left and right, we have to write down that code. The first thing is like, if head is equals to null, head, if head equals to null, what we have done, we simply update the head basically points to root, whichever the root that we have currently we are at. Now next condition is, if previous equals to null, previous equals to null, in that case what we have done, previous equals to root, previous equals to root. Okay, that was the second operation. Now third is like, if previous is not null, that means like whatever the current pointer that we are at root node, so this roots left should point to previous. Okay, and next is like previous right. Okay, previous next, that is how we can consider them, because that's actually asked in the question. So whatever the left and right pointers that we have, it should be previous and next pointers into the circular doubly linked list. Okay, now previous, once it has been done, previous should point to the root. We will shift this previous position to the root, so that same operations we can keep on propagating. Once it is done, we will call simply the right side of the code. Okay, so in between this, if we try to notice, we are doing same operations kind of multiple times, so we can easily modify this code, because previous basically points in the both if conditions. Previous is basically pointing to the root, so in that particular case only, what we will do is we will take this out. Okay, we will remove this code. Okay, only this operation happening if previous is actually null. If previous is basically equals to null, we are updating it, or else we are doing this operation. Okay, and at all the time we are updating this previous equals to null. Okay, so there is should be only one if condition, that is like, if previous is not equals to null. Okay, if previous is not equals to null, then only we are doing it, otherwise previous is getting updated every time. Okay, I think this is how we can modify slightly this code. Okay, once this is done, this particular code we will get it. So head is basically pointing to the I mean the start of the node. So at 3, in this particular example, head is pointing to 3, previous is basically pointing to 2. Now we have to convert it into the circular linked list. This is like a doubly linked list, that is something what we have done. So in order to convert this circular linked list, what we have to do, this 2's, okay, 2 is like where previous is pointing, so previous right. Okay, because previous next right, that is like next is basically converted into the right. So previous right, whatever the previous right that we have, it should point to the head, and heads left should point to the. Okay, that is how we are doing it, right? Like heads left should point to the previous. Okay, the moment that is done, we have to return this head. Okay, this way we can convert it into the circular doubly linked list. I guess this idea is pretty much clear. Let us try to run and see if it is having any issues. No, we don't have any issues. Let us try to submit this code, and it should work fine. So if we discuss about the complexities, we are just traversing them, whatever the size of I mean, if there are n nodes, we traverse through n nodes. Okay, and we are not utilizing any extra space. So yes, in terms of space also, it is like constant big of 1. Okay, so that's how we can solve this particular question. I hope you get the idea, and if so, just make sure to like this video. Thank you for watching this one. Bye bye.